This video is on completing the square. Now keep in mind that this video will not be looking through solving the solutions or maybe even graphing the parabolas in turning point form just yet. That'll be in another video. This video is just solely dedicated to actually completing the square and getting from standard form to turning point form. So those two terms that I just brought up were standard form, and we've been introduced to standard form before. Standard form is just ax squared plus bx plus c. And turning point form was the other thing I used. I'm just going to put t-point. Turning point form is known as a brackets x minus h plus k. Now, if we look at the we'll look at the various transformations in another video. What does A, what does H, and what does K mean? But for now, we just need to understand that HK is known as the turning point. So we'll look at that in another video. But for now, it's just based solely on the skill of completing the square. So how do we complete the square? Well, completing the square just means going from standard form to turning point form. So I want to make, if you can see example 1 is in standard form at this stage. We want to make it turn into something that looks like this. Reasons for this is because it becomes a lot more easier to sketch the graph knowing the fact that you do have its turning point, and it also gives you a few other transformation bits of information as well. So if we want to complete the square, we have to do the following. We remember the form ax squared plus bx plus c. The first thing you need to do is you need to distinguish from this equation what is our b term. So if you just immediately recognize the b term is in fact 4. The coefficient of the x is 4. So what I need to do is, after I find the b term, what I need to do is I need to half it. So what's 4 divided by 2? That's going to be 2. And after I find whatever half of that is, I need to square it. Now, I want you to leave this in this form, because if you realize the similarities between 2 squared and 4, you'll see this will make a bit more sense why I'm leaving it in 2 squared in that form in a second. So what I'm going to do now is I'm going to rewrite this equation. I'm going to rewrite this as x squared plus 4x, but what I'm going to do is I'm going to go plus 2 squared, and I'm going to also minus 2 squared from here. And I'm going to finish off the rest of the equation with minus 12. Now if you notice, I have not done anything to change the equation, the actual values of the equation. And what I mean by that is, if I asked you what 10 plus 2 is, you would say the answer is 12, hopefully. Likewise, if I asked you what's 10 plus 1 minus 1 plus 2, you would still say the answer is 12. So you can see that I've just added a operation and its inverse to there. So this is exactly what I've done just here. I've added plus 2 squared and take away 2 squared as well. Now, the only difference here is that what I'm going to do is I'm going to break this up into 2 sections. I'm going to break this up into first section and the second section. Now, if I look at the first section, if you've watched the previous videos, this would be screaming out at you already. It's a perfect square. I'm not going to go through the working out here just to prove that it's a perfect square, but believe me, it's a perfect square in this case, because you can see for yourself later on. So what this actually factorizes down to is x plus 2 squared. Now, from here, what we see is that we still have the right hand side to work out. Now, this actually becomes minus 4 and minus 12. Now, some of you might be asking, well, isn't a negative number squared always positive? Well, if you look at this case right here, negative 2 squared and negative 2 squared, you can see that these two kind of look similar. However, one is inside the brackets, which means that you include the negative sign as well. So this is the same as saying negative 2 times negative 2. Whereas this is just saying negative 2 times 2. So that's the squared term that you'll be putting inside there. So what we end up getting is from here is that we say this becomes x plus 2 squared minus 16. And that is how you complete the square. That is how you get it into turning point form. So our turning point for this equation is just minus 2 minus 16. Minus 2 minus 16. Because what we came up with was a plus 2, and remember the standard form was minus. So we have to switch the sign of whatever's inside the h brackets. So yeah. So just to clarify once again, whenever you get to this step with x squared plus 4x plus 2 squared, that will always reduce down to a perfect square. We'll see this in the next example. So here we've got something that's in a different form. Now you need to keep in mind, whenever you complete the square, the coefficient of x squared needs to always be 1. So in this case, if you see the x squared, the coefficient of the x squared is in fact negative 1. So we can't actually complete the square just yet. So we need to account for that. We need to arrange some sort of factoring out of that negative. So if I factor out the negative, what happens is this becomes minus 10 minus 6x plus x squared equals 0. And if I rearrange this, what I end up getting is minus, I'm going to put square brackets here, x squared minus 6x minus 10 square brackets equals 0. So now what we need to do is we need to determine what our b value is. It kind of goes against intuition in the sense that everything we've done beforehand, we look at the sign. However, I just want to look at the magnitude of b in this case. So the magnitude of b is just 6. I'm not going to account for that negative. So from here, so you can see that's where I got the 6 from. 6, I'm going to half 6, which is 3, and I'm going to square it there. So I'm going to rewrite this equation now as minus square brackets. I'm using square brackets just to make it look nice and neat. This becomes x squared minus 6x. I'm going to go plus 3 squared minus 3 squared, and I'm going to go minus 10 square brackets equals 0. Now keep in mind, I will just break this up into two sections. So 1, 2, and this reduces down to minus. This reduces down to x minus 3 squared using the perfect square rule, minus 9 minus 10 equals 0. And so this reduces to x minus 3 squared minus 19 equals 0. Now, you might be wondering, why is this minus 0 equals 0 even here? The reason why I've put this equals 0 here is because I just want to take it to the next step. When it asks for equals 0, hopefully you've watched the video on null factor law, where we actually have to come up with solutions to this equation. So what we end up having is, if we take that negative out to the other side, if we cancel out the negative, it becomes x minus 3 squared minus 19 equals 0. So I'm just going to pretty much divide by minus 1, and 0 divided by minus 1 is just 0. So the next step is rearrange so that we get x minus 3, and that's in brackets, equals 19. From here, this becomes x minus 3 equals the square root of 19. Now keep in mind, whenever you take a square root of a number, you need to make sure that you account for the fact that there is a positive and a negative component. So this becomes x equals 3 plus minus 19. And so those are the two solutions of your quadratic equation when you plot them. So the two intercepts. So your two intercepts will be x equals 3 plus root 19 and 3 minus root 19. And your turning point, in this case your turning point, will be equal to, if we refer back to this particular example, is, if we want to find out the turning point, this goes to minus x minus 3 squared plus 19. So therefore the turning point will be 3 and 19. So you need to make sure that if you take a factor out and complete the square, that you need to make sure that you put it back in when you are trying to find the turning point. Let's quickly do this last question because I've realized I'm running out of time for this video. So completing the square, we need to make sure that we have the v squared value as a 1, the coefficient of the v squared as a 1. This becomes 2v squared plus 8 divided by 2 is 4v, and 26 divided by 2 is 13. From here we complete the square. So what's the b term? The b term in this case is b equals 4. So what's half of 4? 2, and we're going to square that. So from here we write 2 square brackets. I'm going to use square brackets just to make it look nice and neat. V squared plus 4v. I'm going to put minus 13 here, and in the inside I'm going to chuck in the plus 2 squared and minus 2 squared. From here what I have is 2 brackets v squared, and I'll just factorize this. So this v squared plus 4v plus 2, that reduces down to 4. Sorry, why did I say 4? V plus 2 squared minus 4 minus 13. And so this becomes 2 brackets v plus 2 squared minus 17. Okay, and if we want to work out what the turning point is, we need to incorporate this factor out the front back into the equation. So this becomes 2v plus 2 squared minus 34. So the turning point for this graph will be at minus 2 minus 34. And just taking it a step further, let's solve. If you wanted to solve this particular equation, what we would get is 2v plus 2 squared minus 34 equals 0. This becomes 2v plus 2 squared equals 34. Divide both sides by 2, so this becomes v plus 2 squared equals 17. If we take the square root, this becomes v plus 2 equals the square root of 17. But remember, whenever we take the square root, it's going to be plus minus. And so this is v is equal to minus 2 plus minus the square root of 17. So therefore, your two solutions will be minus 2 plus root 17 and minus 2 minus root 17. So just to clarify what these numbers mean, this is where your parabola will make a turning point. This is where your first x-intercept will be, and this is where your second x-intercept will be. So if we put that onto a graph, minus 2 minus 34 was going to be around there. Minus 2 minus plus root 17, 4 is going to be around there and there. So that point will look like something like that.